Hi dear student, this is Samuel from Heal Bodhi Classes. Welcome back to AS Level CAE 9702 series. In the last video, we have discussed about the vectors and scalars, vector addition and vector resolution, all those theory we have done. With that video, I have already explained the concepts and the theory part from module 1, physical quantities and measurements of the series. In today's session, we are going to practice structured question. 3 structured questions I have selected. So what I will do is I will post the link of this worksheet with this video. First, you need to download that worksheet and do it by yourself. And then watch the video and check your answers. So if you are getting all correct, means your physical quantities and measurement concept is clear and you are not going to lose mark from this part of your paper. Okay, you can secure your marks. If you're making mistake, means you need to identify which all mistakes you have made in those questions and you need to remember your mistakes, okay? Don't repeat that mistakes in your paper. One more time I will tell you, I strongly suggest that you download that worksheet, do that worksheet by yourself first, then only you watch the solution part. Okay, so we'll move on to the questions. We'll start with the first question. This is the first question. The rate of flow Q of a liquid along a narrow pipe of length L and the radius R is given by Q is equal to alpha R to the power 4 upon L, where alpha is a constant. An experiment is carried out to determine the value of alpha. The data from the experiment is drawn below in the table. So table, the data are given. Quantity Q is measured and with this percentage uncertainty is given. Okay, all the quantities with the percentage uncertainty is given. Use the information from table 1.1 to show the SI base unit of alpha is S to the power minus 1. So you need to show that the SI base unit of alpha is S to the power minus 1. So you have the equation, right? You have the equation which is given as Q equal to alpha R to the power 4 upon L, right? From here you can solve for alpha. Alpha equal to QL upon R to the power 4. Right, you got the equation for alpha now. Using this equation, you can derive the SI base unit of alpha. How? You just substitute the SI units of these quantities in this equation, you will get it. So Q, what is the unit? Meter cube, second to the power minus 1. And length is measured in meters upon. Then R to the power 4. R is measured, right? R is the radius and measured in meter, right? R to the power 4. So you can see that this one will be m to the power 4 second to the power minus 1 by m to the power 4. M to the power 4 will get cancelled. So the unit is s to the power minus 1. So you have proved it. Okay. So B, show that the percentage uncertainty in alpha is 15%. Percentage uncertainty in alpha, delta alpha upon alpha into 100, right? This can be the percentage uncertainty in all these quantities you need to add. First, what is the quantity? Delta Q, right? So delta Q over Q into 100. This is the percentage uncertainty in measuring Q plus delta R upon R into 100. This is the percentage uncertainty in measuring the radius plus delta L upon L into 100. That means this is the percentage uncertainty in measuring that length. So you have written all the percentage uncertainty. Next step, you need to check the power. Okay, power of each quantity. This power is 1. Power of Q is 1, L is 1, you don't need to write that one, but the power of R is 4, that means power always should multiply with the uncertainty, right? Next, you can substitute the values because in this question it is directly given, percentage uncertainty in Q, R and L is directly given, you can use that values. So Q, it is 3% plus radius, it is 2% multiplied by 4, the power, right? Plus in length, it is 4%. So this will be equal to 3 plus 8 plus 4, 15%. Got it? Next question, C part. Calculate alpha with its absolute uncertainty. Give your answer to an appropriate number of significant figures. Okay, the answer, you need to check this one, the answer into 10 to the power 7. Okay, you need to final answer, you need to write with this power. How you can calculate alpha? Alpha, you already have the equation. You solved alpha, right? It is QL by R to the power 4. Substitute the values. Q is equal to 2.72 into 10 to the power minus 8. 2.72 multiplied by 10 to the power minus 8. Length multiplied by length is 2.5 into 10 to the power minus 2. 2.5 into 10 to the power minus 2 upon what is the radius r value? 7.1 into 10 to the power minus 5. 7.1 into 10 to the power minus 5 to the power whole to the power 4, right? So you put these values in your calculator and check. When you do it, so it will be 26.759 multiplied by 10 to the power 6. Okay, 10 to the power 6, that is the value. For calculation, from the calculated value, you write a 3 decimal place minimum, because they are asked to write the answer to appropriate number of significant figures. And also you can see that the answer should be in 10 to the power minus 7. This one, this area you need to check. Okay, you may miss this one. So you need to write it in the form of 10 to the power 7. The power should be 10 to the power 7. How can you do it? If you multiply it with 10, it will be 10 to the power 7, right? If you are multiplying something, means you need to divide it also 10. So it will be 2.676 multiplied by 10 to the power 7. So you got the first part. So next is absolute uncertainty in alpha you need to find out, right? Absolute uncertainty, you can write the fractional uncertainty or percentage uncertainty is equal to 15%, right? So you have calculated that previously, 15%. So delta alpha upon alpha is equal to, you divide this with 100, you will get 0.15, right? What is absolute uncertainty? Delta alpha. That means 0.15 multiplied by alpha, you will get the absolute uncertainty in alpha. So 0.15 into alpha value is 2.676 multiplied by 10 to the power 7. So you put this in, so you put these values in your calculator and the answer will be 4.0139 multiplied by 10 to the power 6. This you can write it as 0.401 into 10 to the power 7, right? You got both the answers, which is alpha and delta alpha, right? Alpha value with this absolute uncertainty. The power is there. Now you can round it off and write it in suitable significant figure. This you can write it as what? 2 significant figure you can write, right? 2.7. So 2.7 here. The absolute uncertainty you can write it in 1 significant figure, so it will be 0.4. So this will be your answer. I hope you got this right. You may have doubt why I am writing all this. You don't need to write all these steps, okay? Just equation and write the values and you can do it. But if you practice this method, you won't make mistake. Immediately, if you directly put everything into the calculator, no, you may make mistakes. So avoid that initially. After a lot of practice, you can do that. Initially follow this method, then understand the concept, understand the method of calculation, then you can skip the steps. Okay? Then next question number 2. The boxes in the figure contains the terms on the left hand side and examples for those terms in the right hand side. Okay, draw a line between each term on the left to correct the example of the right. Okay, one by one we will check. Base quantity. Which one is a base quantity here? Coulomb? No. Electric current, right? Electric current is a base quantity. So quantity, maybe you may confused between quantity and unit. Okay, you need to check this properly. Base quantity means electric current. Okay, base quantity means electric current. Next one is base unit. Base unit, you check. Coulomb is not a base unit. Force is not a unit, it is a quantity, right? Kilogram. Kilogram is the base unit. Mass is measured in kilogram. So mass is measured in kilogram. Next one, derived quantity. Force. Force is a derived quantity, right? Force, what is that? Force F is equal to mass time acceleration, right? So you're deriving it using this formula. So this is a derived quantity. So you can, this is a derived quantity. Derived unit, Coulomb. Coulomb is a derived unit, right? Coulomb is a derived unit means what? How will you derive Coulomb? Coulomb, you know the equation, current is equal to Q over T. So Q is equal to I multiplied by T. So you are deriving the unit using this equation. So it is a derived unit. You need to check every option carefully, then only you will do it. Okay. This is the first part. Second part. A set of experimental measurements is described as precise and not accurate. Okay, remember, it is not accurate. And state what is meant by precise and not accurate. So you know that we already studied this one. How can you phrase this answer? What is precise? Precise means all measurements are close to each other, then it is precise, right? So you can phrase it like all measurements are close to each other. That is the meaning of the readings are precise, right? In this statement. What is accuracy? If and measurements are accurate means what? The measurements, okay, all measurements are close to the true value, or the average measurements, average value of measurements are close to the true value. Here it is not accurate means it is not close. So average value of measurements are not close to the true value. But these topics I have already explained in detail in my accuracy versus precision video. So if you have any doubt in this concept, you can watch that video and clear it. Okay. Next question. An object of mass m travels with a speed v in a circle of radius r. The force acting on the object is given by this equation. F is equal to mv square by r. This is a centripetal force equation. The percentage uncertainty of three quantities are given in the table. The percentage uncertainty in F, M, R is given. The value of V is determined from F, M and R. Calculate the percentage uncertainty in V. So you need to calculate the percentage uncertainty in V. Okay. So you have the equation F is equal to mv square by r, right? F is equal to mv square by r. From this equation, you need to solve for V. V square is equal to Fr upon M. V is equal to root of Fr upon M. Now you need to find out the percentage uncertainty in V. So fractional uncertainty in V equal to, which all measured quantities are there? The force is measured, delta F upon F plus delta R upon R. The radius of the circle is measured, plus the mass is measured, delta M upon M. And everything has a power, right? This you can write it as Fr upon M to the power 1 by 2, right? This power you should multiply with every term, correct? And this is fractional uncertainty. Percentage uncertainty is given. If you multiply by 100, you will get it, right? So that means percentage uncertainty delta V upon V into 100 equal to percentage uncertainty in force, it is 3%, plus in radius it is 4%, plus in mass measurement it is 5%, the whole multiplied by half. So what will be the answer? 9 plus 3, 12 divided by 6% will be the percentage uncertainty in velocity. So you can write the answer as 6. I hope you got it, okay? The value of V is given 15 meter per second. Calculate the absolute uncertainty in V. So absolute uncertainty, you have the fractional uncertainty or percentage uncertainty delta V upon V into 100. This is the percentage uncertainty in velocity, which is equal to 6, right? So delta V is equal to 6 multiplied by V upon 100, which is equal to 6 into, you cross multiply, you're solving it for delta V here, right? So you can cross multiply and write it 6 into, what is the value of V? 15 upon 100. So you put this value in your calculator, 0.06 into 15, which is equal to 0.9. When you round it off, you will get 0.9, okay? So 0.9 is the absolute uncertainty in determining the velocity using these measured quantities. Clear? Next question. State what is meant by work, okay? So work equation we will understand when we study work, energy and power. So now I will give you the definition. Force multiplied by displacement in the direction of force. So force multiplied by displacement in the direction of force. Remember this is displacement, not the distance. Okay, I will explain this clearly in work energy and power chapter. Okay, use your answer in A to show that the SI base unit of the energy is kilogram meter square second to the power minus 2. This equation you can use force multiplied by displacement. Displacement is measured in meters. Here don't get confused, this is mass and this is length. Okay, so mass is kilogram, acceleration is meter per second square multiplied by m. So m will get squared, so kg meter square second to the power minus 2. So you got it, you have proved it. Okay, next question. A metal rod is heated at one end so that the thermal energy flows to the other end. The thermal energy E that flows through the rod in time t is given. Okay, at a particular time, what is the energy flowing through the rod? That is given with this equation. A is area of cross section of the rod, T1, T2 are the temperature at the end, L is the length of the rod, and C is a constant. Okay, so you need to find out the SI base unit of C. SI base unit of C means what? You need to solve for C from this equation. Equation is E CA T1 minus T2 into small letter t upon L. So you need to solve for which term here, because you want to find out the unit of SI. Unit of C means make this as subject and rewrite the equation. C equal to cross multiply this one E L upon A and T to the power T1 minus T2 into T will come down, right? A into T1 minus T2 into T. So you got the equation for C. Now you can derive the units. Okay, energy and work are same quantity in different form. Okay, both having same unit, joule. Since energy and work are same, you can use the same unit. You have derived it here, kilogram meter square second to the power minus 2, right? Multiplied by this length. This L is length, confirm it. Okay, length is measured in meters upon area. What is the unit? Meter square. And temperature change. Okay, temperature change, you remember this one. This is, don't get confused if it is addition or subtraction. You can add or subtract, same quantities only, right? 100 Kelvin plus 50 Kelvin, what is the unit? 150 Kelvin. So you can write Kelvin is the unit for temperature change. Then small letter t was the time, right? Time is given by t, so it will be second. Now rearrange this unit, so it will be kilogram meter square will get cancelled. Kelvin go to the numerator, second is also going to the numerator with a minus 1, right? Second to the power minus 2, second to the power minus 1, meter, Kelvin also minus 1 power, right? So you can rewrite this one, kilogram second to the power minus 3, meter, Kelvin to the power minus 1. Okay, so your final answer will be kilogram, then second meter, next you can write meter second to the power minus 3, Kelvin to the power minus 1. This will be your answer. Okay, so we'll move on to the next question. Define density. You know that definition of density, what is that? Mass upon volume, mass per unit volume, right? A smooth pebble made from a uniform rock has a shape of an elongated sphere as shown in the figure. Okay, length is there, radius is there. This is the shape. The cross section of the pebble in the perpendicular plane of L. Okay, perpendicular plane of L, the cross section, it has a maximum radius at this point, and that is R. A student investigates the density of the rock, makes a measurement to determine the values of L, R and the mass M of the pebble. So the measured values are L, R and M. Okay, state the name of measuring instrument suitable for measuring length. Okay, length value you check, everything is in meters. So when you check the value of L, look, you can see that in centimeter you can measure, right? Centimeter measurement, which instrument you can use? You can use vernier caliper or digital caliper, right? So you can write it as a vernier or digital caliper. Okay, next part is determine the percentage uncertainty in measuring the radius. Percentage uncertainty in measuring the radius. Delta R upon R is the fractional uncertainty in measuring R. You multiply it by 100, you will get it, right? So this will be the percentage uncertainty in R, which is equal to delta R, measuring what is the absolute uncertainty here, 0.0004 upon what is the average value of the measurement of R, which is 0.0420. When you put these values in your calculator, you will get, okay, in calculator I'm getting it as 9.523 into 10 to the power minus 3. Okay, then you need to multiply this. This is a fractional uncertainty in R, right? Multiply with 100, you will get the percentage uncertainty. That means 0.9523, right? This is the percentage uncertainty. You need to round it off. This 0.95, you can write it as 1%, right? One significant figure you need to write. 1% is the percentage uncertainty in measuring R. So we'll move on to the next part. The density rho of the rock from which the pebble is composed is given by density equation is there. Rho is equal to mass R to the power n upon KL. Okay, this is the equation. Where n is an integer, k is a constant with us. So that this k doesn't have any unit, you don't need to consider this one. With no units, which is equal to, the value is also given 2.094. Use SI base unit to show that the number is equal to -2. So number is equal to -2 means which principle will be the principle of homogeneity question, right? I have explained the theory clearly. If you have doubt, you can watch that video, principle of homogeneity. How will you apply? Left hand side, right hand side, the unit should be same, right? In an equation, each and every term will have same unit. That principle you will apply here. Left hand side, what is that? Density mass by volume, right? So kilogram per meter cube. That is the left hand side unit. Right hand, what is that? Mass in kg. R is the radius in meter to the power n. This n notation you need to find out. What is the value for n? Divided by k, you don't need to consider because it doesn't have any unit. L is what? Length in meters. So you can compare both sides. Kilogram, what is the power? 1. So this should be same. So here also, right hand side also, kilogram is 1. Now meter, left hand side meter to the power -3, which is equal to right hand side meter to the power n, and here meter is there, that will come to the numerator to the power -1, right? M to the power -1. So you can write it as left hand side -3, which is equal to m to the power n -1. If you are multiplying, you need to add the powers. So left hand side and right hand side equal means what? The power here left hand side should be equal to power on the right hand side, right? So it will be -3 equal to n -1. So n is equal to -3 plus 1, which is equal to -2. So this is -2. You have proved n is equal to -2. Got it? Next part is calculate the percentage uncertainty in the row. So how can you calculate the percentage uncertainty in density? Fractional uncertainty in density, delta rho by rho, multiplied by 100. Finally, you can multiply it, okay? Fractional uncertainty in density equal to, which all quantities are measured in the equation? M, R, L, right? So delta M upon M. What is this? Fractional uncertainty in measuring the mass, plus delta R upon R. What is this? Fractional uncertainty in measuring the radius. One more quantity is there. What is that? Delta L upon L. Delta L by L, the fractional uncertainty in measuring the length. After writing that fractional uncertainty equation, you need to check the powers, okay? Powers of the quantities. M and L has power 1. You don't need to write that, but R has a power n, right? That you already find out, that is -2. So you need to multiply the power of R with the fractional uncertainty in R, right? So you multiply here this one with the -2, right? That is the value of n. But remember one thing importantly, this minus n, you will never subtract uncertainties. It will always get added up, okay? So delta M by M, the values you can write it here. 0.001 upon 1.072, that is the average value, plus R. Delta R is 0.0004 upon 0.0420 plus 0.0001 upon 0.1242. Okay, the values there in the question, you can substitute that values, and here multiply with the 2, not with the -2. Okay, it will always get added up. For example, I will show you in here. M R to the power -2 upon what? K into L, right? Minus 2 means what? In this equation, this minus 2, you can send it into the denominator. K L R to the power 2, right? You need to multiply here with the 2. Delta M by M, delta L by L, delta R by R. R has a power 2. You need to multiply. Don't use this minus sign and reduce it from the calculation. Uncertainty always get added up. You are not supposed to subtract it. Keep this in your mind. Clear? And finally, you can multiply the whole thing with 100. You will get the percentage uncertainty in measuring density. So when you substitute all these values in your calculator, you will get 0.020. Then you need to multiply with 100. That means 2%, 2.0%. So you can write it in single significant figure, which is 2%. So answer will be 2%. I hope you got this right. Next part, determine density with its absolute uncertainty. Give your values to appropriate number of significant figures. Significant figures you need to always take care, okay? So density is equal to M R to the power minus 2 upon K L, right? That was the equation. M R to the power N upon K L, okay? So you substitute all this value. Mass 1.072 multiplied by R 0.0420 to the power minus 2 upon 2.094 multiplied by 0.1242. When you put these values in your calculator, you are getting 2.3366 multiplied by 10 to the power 3 kilogram per meter cube, right? Density you are measuring. Then now you need to find out absolute uncertainty in the density measurement, right? Delta rho upon rho is equal to 2%, right? That means 0.02, correct? 0.020. So delta rho is equal to 0.020 multiplied by the density. Density value is 2.3366 multiplied by 10 to the power 3. So when you put this in your calculator, you will get it as 46.73 kilogram per meter cube. You got both the values, absolute uncertainty in density and the average value of density. Both you need to write it in proper significant figure, okay? Suitable significant figure you can write. You check this one. When you multiply this with 1000, you can write it as 2336.6. You can write 2337, right? So this is 4 significant figure. So you can write it in 3 significant figure. It will be 2340. And absolute uncertainty you can convert. You can round it off to 1 significant figure. 46.73. You can write it as 47. 47 is 2 significant figure. You can write it as 50 kilogram per meter cube. Okay, 1 significant figure. So this will be your answer. You may think that why I am writing it in 3 significant figure. Here it is 4 significant. Why I am converting it into 3 significant figure? Because with the measured values, when you check the measured values, this is important, okay? Measured values, you need to check what is the least significant figure. Least significant figure. Look at this one. The R is having the least significant figure, right? It has only 3 significant figure. So my answer should be in that number of significant figure. Understood? The least value of significant figure in the measured value. So that is why it is 3 significant figure and the absolute uncertainty in 1 significant figure. Got it? Understood? With this question, we finished the practice session. If you have made any mistake in the calculation or stepwise, you just remember your mistake, okay? Don't repeat it in the next question. Like that, you need to practice. Practice more questions, and after 5 to 10 questions, you are not going to lose any mark from this session. So if you have any doubt in any topic, you just comment in the comment section. So what I will do is your doubts in any part, I will make a separate playlist for the doubt clearance session in module 1. When I get enough doubts from your side, I will create a video to clear that doubt. Okay. Next part will be the MCQ practice session. So when we finish that practice session, means this module is completed. We can move on to the next module, module 2, kinematics. Okay. You need to follow this order. If you follow this order, order of the content, then you will remember it. You can remember it easily. Okay. So you practice and comment your doubts in the comment section. This is Sanal from Hilbodhi classes. See you in the next video. Bye.